Today we're going to show you how you can blow CD bubbles. For this you're going to need a CD, a lighter, and a pair of scissors. Place your CD on the table with the surface facing upwards. Then use your pair of scissors to gently scrape off any of the covering. When you've done that, you'll be able to see straight through the CD. The covering should come off quite easily. Once that's done, brush off any of the remains and check that you can see all the way through. Then take your lighter and hold it underneath the clear part of the CD for about 5 to 10 seconds. You should see the surface of the CD start to melt. When this happens, turn off the lighter and blow. By heating up the plastic, you've thinned it out, and you're able to blow it out like a balloon. This is a really cool party trick. The plastic's so thin that they'll move on the breeze. They look like they're alive. And there you have it. That's how you can blow CD bubbles. Rubber Band Watermelon Challenge. You're simply going to need a watermelon and a lot of rubber bands. Place your watermelon on a stable surface, outside. Then, start to add the rubber bands. Wrap them around the circumference of the watermelon. This is going to need a lot of rubber bands, so make sure that you're patient. You can always get someone to help you with this if you think you bore easily. As you can see here, I got a helping hand from a few friends, and we used something like 200 rubber bands. If you look closely at the watermelon, you can probably see that it's very slightly changed shape. What's happening here is that by adding rubber bands to the surface, we're putting a lot of pressure onto the watermelon. That pressure is all directed into the same part of the fruit. Now if we look here, you can see that some of the juice of the watermelon is starting to pour out because a crack has formed in the top. Let's keep adding a few more rubber bands to see what happens. Keep an eye on the top part of the watermelon. At this part, there are 420 rubber bands on the watermelon. You'll have to be patient, as this can take some time. If you like, you can try spreading the watermelon yourself, and eventually the pressure will build up. You see here the bottom part of it is split, and now the pressure of the rubber bands is really starting to take hold. In just a few more seconds, pop! We've completely cut the watermelon in half. It goes so fast, we almost can't see it even when we slow down the video. It's important to do this outside, as any juice and pieces of watermelon will create quite a mess. But at least you've got a snack for afterwards. And there you go. That is the Rubber Band Watermelon Challenge. Where is gravity? For this experiment, you're going to need some magnets, sellotape, string, a box, and a nail. The first step is to take your string and your nail and tie a very tight knot around the nail using your string. This might be a bit fiddly, so stay with it. Once that's done, make sure the knot is extremely tight. Then place your nail to one side. Take your magnets and your sellotape. This experiment works best if all the magnets are arranged in one column. Once you've done that, take a length of sellotape, place your column of magnets into the centre, and stick the sellotape firmly to both sides. There we go. Once you've done that, take your box and carefully stick the column of magnets to the top of the box. Again, this might be a little bit fiddly. Make sure that the sellotape is stuck firmly in place. Once that's done, take your nail and string and hold the nail close to the column of magnets. As you do that, you'll feel that it starts to attract to the column of magnets. That's because the nail is made of iron. And as we know, iron is a magnetic conductor. Once you've figured out the point at which the nail is attracted to the magnets, put the nail down and use the sellotape to stick the string firmly in place. Then very carefully lift the nail back into place until it is attracted to the magnets. The string will hold tight and stop the nail from being fully attracted to the magnets, and make it look as if the nail is hovering in mid-air. This is a really cool experiment, and it demonstrates the balance between gravity and magnetic attraction. If you show this to friends, you can prove that it's not a trick by running something thin like a pencil or a straw in between the nail and the magnets. You can even take the nail down and put it back into place. It will hold just as firmly. Why don't you see how much effort it takes to knock the nail out? Isn't that great? And that's how you ask, where is gravity? DIY macro lens. You're going to need a laser pen, a hairpin, a smartphone with a camera, some pliers, and some sellotape. First, carefully use the pliers to remove the end from the laser pen. You can see what looks like a small glass bead in the end. This is in fact a very small lens. This is what focuses the laser in your laser pen, and we'll need it to make our macro lens. Then take your phone. Turn it over to see the camera. Then clip the lens from the laser pen into your hairpin. Place the lens directly in front of your phone's camera. Then use a piece of sellotape to hold the hairpin in place. Make sure it's secure. Then turn your phone back round and open up the camera. If you look through, everything will look very blurry. But this is where it gets really cool. Take something with a lot of detail in it, for example this £10 note. Hold the camera closer and closer to the object, and suddenly you'll see everything is in focus. Using the lens from the laser pen, you've created a macro lens. A macro lens allows cameras to see things really close and in great detail. For example, if we hold our lens very close to this £10 note, you'll see that the swirls on the money are actually made up of lots of the word 10. If you hold it close to the eye, you'll see there's lots of circles. You can try lots of other objects, like this 50p coin. It lets you see loads of detail. You can see hundreds of tiny scratches on the coin that you wouldn't normally be able to see. Why not try zooming in on your phone camera? This will allow you to look even closer. I love this trick because it's a really great way to take something you already have and make it even better. That's what you call a hack. If you like taking photos with your phone as much as I do, this will allow you to take loads of cool new pictures of things you wouldn't normally be able to see. Here are some photos that I've taken. You can see an incredible amount of detail. Look at those tiny dots. And look at this rusty screw. You can really see the tiny bits of damage. Isn't that great? And there you have it. That's how you can make a DIY macro lens. Twist in time experiment, which is really great fun. You're going to need 4 clips, a glass and a smaller glass, 3 different types of food colouring, 3 small tubs, 3 pipettes, some liquid hand soap, a jug of water, and some adult supervision. The first step is to take your larger glass and add a small amount of liquid hand soap. Then take your smaller glass and place it inside. Do this slowly so that you don't add too many air bubbles to the mixture. You'll see that the hand soap starts to run up the inside of the larger glass. Then fill the small glass with water. This will help to weigh it down and hold it in place. Take one of your clips and place it onto the rim of the larger glass. Take another clip and place it on the opposite side. Place a third clip and leave a space for the fourth. Then take your 3 tubs, pour a small amount of hand soap into each of them, then add a few drops of food dye into each tub. 2 worked well for me. Make sure that none of the food dye gets mixed up. Then use your pipettes to mix the food dye in with the hand soap. This might take some time to do properly, but it's well worth it once it's finished. Again, make sure that the pipettes do not mix. Take your glasses. Very carefully use the pipette to suck up a few drops of the food dye and soap mix. Then, very carefully, place the pipette into the layer between your large and your small glass. Go about 1 inch down into the soap. Squeeze some of the mixture into the liquid and pull it out again. Make sure that you're very careful as you do this. Repeat this step twice, once with each colour. Try to remove any air bubbles from the pipette before you squeeze out the mixture. This will help the experiment go much more smoothly. You'll see that as you squeeze the mixture out into the soap, it forms a small pool and then remains. This is because the soap is very thick. Try to hold the glass very still as you do this. Once all 3 colours have been placed, put your last remaining clip into its spot. Then, very carefully, turn the inner glass. You'll see that the 3 colours start to blend together, almost disappearing. That's the end of that, isn't it? Well, perhaps not. Turn your glass back in the opposite direction, and you'll see that the colours come back. They haven't mixed together at all. But why is this? Well, we're still not quite sure of the exact reason ourselves, but the best explanation is that when you put the three colours into the mixture, they actually form three separate layers, each on their own. When you turn the glass, each layer is spread out thinly. When you turn the glass backwards again, the layer returns almost to normal, but they never mix. Isn't that great? And that's how you can perform your own twisting time experiment. How to draw in 3D. Now this is awesome, and all you're going to need is some paper, a pencil, and 2 markers. Place your hand carefully onto the paper and then draw around slowly with your pencil. Make sure that you get a really good outline for your hand, but don't push the pencil down too hard. You'll catch all the little quirks on your hand. For example, my little finger is slightly bent. Once that's done, take one of your pens and then start to draw horizontal lines across the page. When you get to the outline of your hand, curve the line slightly, like a little bridge over a river. Then when you get to the other end of your hand, continue with the straight line. Proceed up the page, continuing this as much as possible. Whenever you get to a part of your drawing, make sure that you curve the line. This might mean that your horizontal lines end up slightly unequal, but that's okay. As we draw, you can see that the hand starts to look as if it's pushing its way out of the page. This is what we call an optical illusion. To add to the illusion, you can add more lines. You can of course use a ruler to make your straight lines completely straight if you like, but I find it's more enjoyable to try and do it completely handheld. You can use any colours you like. I chose purple and red. I think this is a really great trick to show your friends. Why not try it with different objects and different colours? To add to the effect, you can use your pencil to work around one side of the drawing and add shadows. This will make your shape look much more three-dimensional. What do you think of my drawing? I think I did really well. Why not try it with different shapes and objects and see what works best? And that is how you draw in 3D. Invisible bottle. For this, all you're going to need is a small bottle, a glass, and a tall glass with some glycerin in it. Firstly, pour some glycerin into your glass. It should be about 1/3 full. Place the glass to one side. Take your small bottle and remove the cap if there is one. Then very carefully fill the bottle with the rest of the glycerin. This might take some time. Once that's done, place the large glass to one side and very carefully place the small bottle inside of the glass. Once it reaches the bottom, you'll see that it seems to disappear. You can't see the edges of the bottle anymore, and this is because of refraction. Both the glass and the bottle are full of glycerin, which refracts or bends light in the same way. This means it's much harder to see what's inside the glass. You can just make out the small air bubbles inside the smaller bottle. If I place my hand behind the glass, you can see it's still very difficult to make out the shape, unless you get very, very close. And there you have it. That's how you can make your very own invisible bottle. Brilliant! Matchbox microphone. The first step is to take a matchbox, some scissors, some electric cables with clips, a few pencils, a sharp craft knife, a pair of headphones, and a battery. Make sure that you have an adult help you with this experiment. The first step is to empty your matchbox, take the drawer from the inside, and use a sharp pencil to make 2 holes in each end of the matchbox. Then, using the craft knife, and with adult supervision, carefully cut your pencil in half. Once that's done, use the knife to very carefully remove the graphite from inside the pencil. You'll need a few sections of this. 2 of the sections will slot through the matchbox holes, so make sure they're long enough. Once you've got them, use the pair of scissors to carefully file down one side of the graphite to create a flat surface. Push these 2 pieces of graphite through the matchbox with the flat surfaces facing upwards. The pencil shavings will make things a bit dirty, but don't worry, that's all part of the fun. Then, take a shorter piece of graphite and once again file down one side to make it flat. Break a few pieces off if it's too long to fit inside. Then place it on top of the 2 pieces of graphite with the flat side down. This will help it stay still. Take your battery and attach one cable onto the positive end. Attach the other end of the cable onto one piece of graphite. Attach another cable to the second piece of graphite and a third cable to the negative end of your battery. Take your headphones, clip the second cable onto the bottom of the jack and the third cable onto the top. Then take your headphones and pop them in your ears. Carefully tap the matchbox. You should very clearly hear the sound transmitted through the headphones. This is because the graphite is a conductive material. It allows a circuit to be created by attaching the cables using the battery and the headphones. And there you have it. That's how you can create your very own Matchbox microphone. Snake bubbles. All you're going to need is some rubber bands, a big plastic bottle, a pair of scissors, some white socks, a small plastic bottle, some food colouring, bubble mixture, and a glass. Firstly, carefully use your scissors to cut off the bottom of your large plastic bottle. It's best to ask a parent to help you with this, as the scissors may be sharp. Smooth off the edge of the bottle so there are no sharp pieces. Then take your sock and again use the scissors to cut along the end of the elastic part of the sock. Then carefully stretch the fabric of the sock around the bottom of the bottle. Pull it tightly so you create a sort of drum made out of material. Make this surface as tight as you can. Once that's done, use a rubber band to hold the sock in place. Next, pour your bubble mixture into a container. Make sure that the container is wide enough for you to dip the bottle inside. Take the bottle and dip the sock end into your bubble mixture. Make sure there's plenty of mixture on it. If you blow into the neck end of the bottle, you'll see that you create thousands of tiny bubbles. This is because the fabric of the sock has tiny holes inside, creating lots of little bubble blowers for you. Now, how can we make this more interesting? I've got an idea. What you need to do is take your food dye and pour some over the end of your bottle. You can do this in spots, in stripes, or you could just completely soak the end of your sock in food dye. I'm going to start with a little red and blue, just to see what happens. Let's cover a good amount of the surface in food dye. Once that's done, take a deep breath and blow. You can see that as the bubbles come through the sock, they soak up some of the food dye, creating coloured bubbles. This is a really fun experiment. You can try with all sorts of different coloured food dyes. You could even try different socks to see what gives you the best bubbles. And that's how you can make your own snake bubbles. Glowing balloons. This is a great, simple experiment. You're going to need some balloons and some LED lights. That's it. The first step is to remove any key rings that might be attached to your LED light. Check that it's working before you carry on. Once you're sure it is, turn the switch to the on position. Then, carefully open up one of the balloons and put the LED light inside. Once that's done, carefully inflate the balloon. Don't blow it up too hard, just to make sure that the rubber isn't stretched too much. Once that's done and the LED light is inside, switch out the lights. And there you have it. The balloon is glowing. The LED light will sit inside and illuminates the surface of the balloon. Because the rubber is slightly reflective when it stretches, it will bounce the light around the inside of the balloon, creating a glow. You can try this with different colours of balloon. We found that a blue light inside a blue balloon works particularly well, or that a white light inside any colour tends to work fairly well. You can shake the balloons around to create really cool lighting effects. Why not try different colours of balloons to see which one looks best? You can try using lots of the same colour of balloon, or mix and match different colours to see what you can do. This is a great idea if you're having a party, or if you want to create a really cool atmosphere. And there you have it. That's how you can really easily make some glowing balloons. Fireworks in a glass. You're going to need a plastic fork, a container, some vegetable oil, a glass, and some different colours of food dye with droppers. The first step is to take your small container and pour a small amount of vegetable oil inside. Just a couple of teaspoons should do the trick. Now it's time to add your food dye. The best way to get this to work is to add very small drops into the oil, one at a time. Try to add the colours separately so that they don't mix together. You'll notice that each colour forms its own small droplet suspended inside the oil. You can then use the fork to very carefully stir the mixture together, and you'll see they form even smaller droplets. Pour the oil into the glass of water. You'll see that the oil floats on top, and that the colours are suspended inside. However, the food dye is slightly heavier than the oil, which means it gradually reaches the bottom of the oil and meets the water. When it meets the water, it seems to erupt into it like a firework. This is a really cool effect. You can try all sorts of different colours to see which ones work best. You'll notice that the colours haven't really mixed. This is because they stayed as very small droplets suspended in their own bubble of oil. You can try adding extra drops using the dropper into the top of the oil. See how that affects your fireworks. You can see that if we flip the video around, it really does look like fireworks exploding in the sky, or maybe even erupting volcanoes in the distance. It looks like the surface of an alien planet. And there we have it. That's how you can make your very own fireworks in a glass. Bending water experiment. This is really simple. All you're going to need is a balloon. Firstly, stretch out the balloon to make sure it's easy to blow up, and then take a puff and blow it up. Once that's done, tie a knot in the end so the air does not escape. Then take your balloon over to a tap and borrow someone's hair. Rub the balloon against their hair and you'll see that their hair stands on end. Once it's doing that, take the balloon close to the tap of running water and see what happens. The balloon seems to attract the stream of water from the tap. This is because when you rubbed the balloon on your friend's hair, it picked up a charge of static electricity. Then when you hold the balloon close to the water, this electric charge attracts the water to it. This is because water is a conductive substance. Move the balloon closer and further away from the water and see how it affects the stream. Isn't that great? And there we have it. That is the bending water experiment. DIY smartphone speaker. You're going to need some sellotape, a marker pen, a pair of scissors, a smartphone, a few plastic cups, and a cardboard tube. The first step is to take your cardboard tube and your phone. Then use the marker pen to mark the rough outline of your phone. Once you've done that, carefully use your scissors to make a hole in the cardboard tube. Then cut around the line. You want the phone to fit quite snugly inside the tube, so it's best to make the hole slightly too small at first. You can always cut it larger. Once it's big enough, check that your phone fits, and then place it to one side. Then take a few of your plastic cups and draw around one end of the tube on one cup and make a similar mark on the other cup. Make sure that they're in roughly the same spot on each cup. Once you've done that, again carefully take your scissors then cut a cross shape inside the hole. Bend the plastic back and you should be able to fit the tube inside. If this doesn't quite work, try making 8 cuts instead of 4. The tube should fit tightly inside. Repeat the process with the other cup. Once that's done, take some sellotape and secure the tube in place. Then all you need to do is load a song or a video, place your phone inside the tube, and there you go. The sound waves travel from the speaker in your phone down the cardboard tube and into the cups. The shape of the cups amplify the sound, acting as speakers. This is a really good trick if you're having a party or if you're with friends and you want to enjoy some music. Boil water with ice. For this experiment, you're going to need a chopping board, a thermometer, a frying pan, a glass bottle with some water inside, a glass, and some ice cubes. The first step is to place your pan on top of the hob, put your bottle inside the pan, and then turn on the gas. If you have an electric hob, you don't need to use a frying pan. You can just place the bottle directly onto the hob. The water will heat up and start to boil. Once it reaches boiling point, carefully remove it from the pan and screw the lid back on top. You'll see that the water is still bubbling. Place your bottle upside down inside the glass. Then place a few ice cubes on top of the bottle. You'll notice that the water has stopped bubbling. But when you place the ice on top of the glass, it will start to bubble again. Keep your eye on the water. You'll see that as the ice sits on top of the bottle, the water starts to boil again. This is because the ice on top of the bottle cools down the air inside. This reduces the pressure and lowers the boiling point of the water, meaning that instead of having to reach 100 degrees Celsius, it only has to reach a lower temperature in order to boil. So you're literally boiling water with ice. I think that's pretty cool. The ice will start to melt as it's on top of the bottle, since the bottle is warm. If you like, you can replace them with fresh ice cubes to keep the experiment going. We let the water boil for a while, then turn the bottle back the right way up and measure the temperature of the water. It was at approximately 70 degrees Celsius, meaning we got water to boil at only 70 degrees instead of 100, which is pretty cool. And that's how you can boil water with ice. Sugar magic. For this experiment, you're going to need a spoon, a plastic cup, some lemon Kool-Aid powder, sugar, and some water. The first step is to put a heaped spoonful of sugar into your plastic cup. Then empty the packet of Kool-Aid powder into the sugar. Mix the two together and very quickly it will just look like a cup of sugar. Then simply add the water. And hey presto, your sugar has turned yellow. This is a really great and really simple trick that you can try on your friends. You can challenge them to make sugar change colour and then show them how it's done. And there you have it. That's how you can make sugar magic. The amazing balancing coins. All you're going to need is a bag of coins. First, place 2 coins hanging slightly over the edge of the table. Then 2 more behind those, and another behind those. Then place 2 coins over the join between the others. You want to make a sort of pyramid shape. Balance another coin over the edge of the first coin, and use another coin to weigh it down. The way this experiment works is by balancing the weight of the coins on top of each other with the force of gravity. As gravity pulls the coin down, the weight of another coin on top of it pulls it the other way, balancing it out. This will stop them from falling. As you place the next coin, try to make a horseshoe shape. You can just nudge the coins slightly towards each other to create this shape. The more coins you add to the middle of the stack, the greater the weight pushing them down. This will help to hold it securely. What you want to do is create a complete U shape using the coins. This might take you a little while and you will have to be very delicate, but it should hold properly. Just see if you can add a couple more coins at the end. If you look at it from the side, you can see that it's quite a thick stack and that they are hanging fully over the edge of the surface. It's a surprisingly secure structure. I've made mine on the edge of a tile so that I can lift it up and show you. And there you have it. That's how you can make amazing balancing coins. Growing and shrinking eggs. You're going to need 2 eggs, some distilled vinegar, honey, 2 small cups, and a large cup. Place your eggs inside the large cup. Then completely cover them with your vinegar. Straight away, you'll start to see bubbles form on the surface. Place the cup to one side for a few hours, or overnight if you prefer, and then come back to it. You'll see that layers of the shell are starting to peel off. If you rub your thumb along the outside, you can see that it's changed colour. If you squeeze it, it feels very soft. Soak the eggs in vinegar until they're completely soft. Once that's done, place 1 egg inside a small cup and cover it with more vinegar. If you like, you can mark the cup with a V. Then place your second egg gently inside the other small cup and completely cover it with the honey. The honey is thicker, so this might take a bit longer, and you might need to move the egg around inside the cup to completely cover it. Make sure that the egg sits in the middle of the honey. You may need to use something small and slightly heavy to weigh the egg down, as it might float. We use this small glass. Then place both of your cups aside overnight. Rinse them out in the morning and see what you've got. You can see that the egg that was sitting in the honey has changed colour and turned to the same colour as honey. The egg that was sitting in the vinegar has gone transparent. You can see the yolk of the egg in the middle. But you can also see that the eggs have changed size. This is because soaking the eggs in vinegar breaks down the shell and means that the eggs are able to absorb more moisture through something called a membrane. This is the soft, squishy thing on the outside of the egg. You'll note that the vinegar-soaked egg bounces much like a bouncy ball. If you hold the honey-soaked egg, you'll see that it's also shrunk slightly. You can even feel the yolk sitting in the middle of the egg. This one won't bounce either. You can compare the two next to a normal egg, which will really illustrate how they've changed size. The honey-soaked egg is smaller, and the vinegar-soaked egg is larger. This is a really cool experiment. Why don't you try it with some other liquids to see how it affects the eggs? Perhaps milk or a soft drink. You can even pick up the honey-soaked egg, which feels really strange, like a tiny water balloon. And there you have it. That is growing and shrinking eggs. Chemical chameleon. You're going to need a stirrer, sodium hydroxide, potassium permanganate, sugar, a beaker of water, and a flask of water. Take your sugar and your sodium hydroxide and pour them into your beaker of water. Use your stirrer to stir them together. Then pour some of your potassium permanganate into your beaker of water. You'll only need a few grains, enough to make the water change colour. Make sure this is mixed thoroughly. Then pour your sodium hydroxide mixture into the flask. You'll see that the solution changes colour from purple to a bright blue, then green, then yellow, and then a bright orange. This colour change happens because of the strange chemical interaction between the mixtures in the glass. Viewed from above, it's a really strange combination. And there you have it. That is the chemical chameleon. Mint really does cool things down. You're going to need some mints, a piece of paper, a thermometer, a pen, and a glass of water. When you pop a mint into your mouth, it tastes quite cold. So we wanted to find out whether it actually made things colder or whether that was just a feeling. Place your thermometer inside the glass of water. Then take out your pen and paper, and you're going to use this to keep track of the temperature of the water. Before you go any further, make a note of the temperature of the water before you put any mints into it. Ours was 29 degrees Celsius. Take one of the mints out of the packet, stir it a little, and after 1 minute, take the temperature again. Make sure you make a note once every minute. This will help you to judge the progress properly. After 10 minutes, write down your final measurement. You can see here that all of our measurements were 29 degrees Celsius. So from this we can say that adding mint to water really doesn't do anything at all. So mint doesn't cool things down. Do-it-yourself projector. You're going to need a cardboard box, a magnifying glass, some gaffer tape, a scalpel, a pair of scissors, and a pencil. The first step is to use the scalpel to remove one of the flaps from the box. When that's done, take your magnifying glass and hold it against one side of the box. Use the pencil to carefully draw around the magnifying glass. Use the scalpel to carefully cut out the circle shape. It's best to ask an adult to help you with this part of the experiment. Make sure to be careful when using the scalpel. Once you've cut out the circle, fit the magnifying glass into place. You might be able to remove the handle from yours. We couldn't, but that shouldn't affect things too much. Use some of the gaffer tape to secure the magnifying glass in place. This creates the lens for your projector. Then, take the piece of cardboard that you cut off earlier and fold it up to make a stand for your phone. Check that your phone fits securely onto the stand. Once you've done that, load up a video onto your phone. You'll need to change your phone's settings so that the screen doesn't rotate and then place the phone so that the video plays upside down. When the image transfers through the magnifying glass, it will be turned around the right way. Take the box into a dark room and there you go. The image is projected onto the wall, and you've got your own cinema at home. You'll need to try moving the phone around into slightly different positions and angles in order to get the clearest picture, and it's never going to be as clear as it is at the cinema, but it's still a really cool trick that you can do very easily at home. And there you go, that's how you can make your very own do-it-yourself projector. Explosion that sparkles. For this experiment you'll need a tray, some glitter, vinegar, a beaker, some food colouring, a vase, baking soda and a spoon. Place your vase inside the foil tray and 3 tablespoons of baking soda into the vase. Then sprinkle some glitter in. For this first round we've used blue, gold and red. Use the handle of your spoon to stir the solution. And then add a few drops of food colouring. All you need to do then is add the vinegar. You get an instant reaction that's full of sparkles. It's important to use something like the foil tray to contain the mess. If we show you up close, you can see all the different colours of glitter. If you'd like, you can use more food colouring to create coloured foam. And as much glitter as you like. So there you have it. That's how you can create an explosion that sparkles. Funky fountain experiment. This is great fun, and all you're going to need is a straw, a screwdriver, the bottom half of a plastic bottle, a large tub and some water. Take the bottom of your bottle and your screwdriver and poke a hole into the bottom of the bottle. Make sure that you have an adult present when you're doing this. Be patient, as it might take a little bit of time. Make sure that you have a really good, neat hole. And then check that your straw fits through the hole. It should be big enough to let the straw in, but tight enough to hold it in place. Then take your straw out, bend the top end over, and poke the straw through the bottom of the bottle. Make sure that the shorter end of the straw is on the inside and touching the bottom of the bottle. Once that's done, hold the bottle in the air and pour a small amount of water inside. You'll see that the water remains inside the bottle. As the water level rises, nothing happens until the water level reaches the same height as the top of the straw. And out comes the water. How does this work? Well, really, it's all about pressure. The lower end of the straw is at a lower pressure to the upper end of the straw. Once the water level reaches the bend in the straw, this pressure difference forces the water out of the straw. This experiment works as the bottle is open, and so air is able to flow freely into the bottle, creating the low pressure. Once the water level reaches the bottom of the top end of the straw, you'll see that the water flow stops. If we look back at the experiment, you can really see that nothing happens at all until the water level reaches the bend in the straw. This experiment will work with a really long straw or a really short straw. The principle remains the same. You can try it with different liquids to see how they move. Water is the easiest to work with, as it's not very messy and flows very easily. Why don't you challenge your friends to make their own? That way you can have a race and see whose works the best. See what happens if you use different straws. And there we have it. That is the funky fountain experiment. Flaming candle seesaw. You're going to need a flat surface, a needle, a long candle, some matches, a pair of pliers, a knife, and 2 small glasses. Firstly, carefully cut around the middle of the candle. Don't cut all the way through because you want to keep the wick. Once you've split the candle in half, you can use the knife to cut through the wick. Make sure there's a bit of wick on each end of the candle. Then, using the pliers, carefully guide the sewing needle through the middle of the candle. It's best if you get an adult to help you with this part, as the needle of course is quite sharp, and it also might be a bit awkward. Once that's done, take your 2 glasses and space them apart, just enough so that the candle can sit in between them. The needle will sit on the edge of the glass and act as a pivot point for your seesaw. The first step is to light the lowest end of the candle. As the candle burns, it will drip off wax, making that end lighter and help the candle to balance. When it's nearly balanced, light the other end of the candle. Once that end is lit, it will start melting wax off that end. Each of the ends of the candle will start to drip wax, which means they alternate getting slightly lighter, creating a seesaw effect. As the candle burns and gets shorter, you might find that this seesaw effect starts to speed up. The best thing about this experiment is you can use the other end of the candle to repeat the experiment and see how it's different. And there you have it. That's how you can create a flaming candle seesaw. Experimenting with water flow. For this, you're going to need a small platform, a short straw, a long straw, a tray, a bottle top, a pound coin, an empty water bottle, another bottle top, and a bottle of water. The first step is to take your bottle and have an adult help you make a hole in the bottom of the bottle, about 2 inches from the bottom. Make sure it's big enough for your straw to go all the way through. You might want to use some blue tack to strengthen the seal between the bottle and the straw. This might be a bit fiddly, so you might want to get an adult to help you. You'll also need an adult to help you make a hole in the middle of your bottle cap. Once that's done, you can take your long straw and push it through the hole, leaving a short amount of the straw showing at the top of the cap. Then take some more blue tack and place that around the edge of the straw and the cap. Again, this will help to strengthen the airtight seal between the two. Once that's done, take your tray and your platform and place them closely together. Put your bottle on top of the platform and have your cap and straw at the ready. Unscrew your bottle of water. Keep your finger over the end of the short straw and carefully fill your bottle with water. You might spill a bit of water, but that's okay. Once you've poured all the water in, Take your cap with the long straw and screw it tightly onto the top of the bottle. Then take your finger off of the end of the short straw. You'll see that water flows at a constant rate out of the bottle. You can place your coin inside the tray to track where the water is landing. You'll see that it's landing at exactly the same point the entire time. This is because the straw helps air to enter the bottle at a constant rate, keeping the pressure the same. This pushes the water out of the bottle at the same rate. You can see the bubbles inside the water as air is pushed down through the straw. Once the water level goes below the long straw, you'll see that the water pressure changes. It starts to lower, and water leaves the bottle much slower. You can try refilling the bottle. Place your coin under where the water is landing, and then very carefully raise and lower the longer straw. You'll see that the height of the longer straw in the water affects the rate at which it flows out of the bottle. This is because you're changing the air pressure and the air flow. And there you have it. That's how you can do your own experiment with water flow. Dancing ghost. Ooh. For this experiment you'll need a balloon, a ruler, some scissors, a Sharpie and some crepe paper. Firstly, take your crepe paper and your pen. Fold the crepe paper over a few times and then use your marker to draw the outline of a ghost on your crepe paper. Try and make it as scary as possible. This won't make the experiment work any better, but it will make it look much cooler. Once you've finished drawing your ghost, take your scissors and very carefully cut around the outline. Make sure that you cut a few layers of paper at the same time. This means that you'll end up with a few ghosts instead of just one. Don't forget that because you're working with scissors, you will need to have an adult present. Once you've done that, lay all of your ghosts out side by side. Take your ruler and place it on the counter. Then place the bottom edge of each of your ghosts underneath the ruler. This will hold them in place during the experiment. Then take your balloon, rub it against someone's head, and move it near the ghosts. You'll see that the ghosts seem to reach up and try and grab the balloon. This is because the static charge that your balloon picked up from your friend's hair attracts the paper. And there we have it. That is the dancing ghost. The hidden holes bottle prank. You're going to need some thumbtacks, a large bottle of water, and a permanent marker. That's it. Firstly, place your bottle on its side, and then write a tempting message, something that might make someone want to drink what's inside. We kept it simple. Do you think this will work? Once you've written your message, take your thumbtack and then turn your bottle over. Very carefully, make a few holes near the bottom of the bottle. As you do this, water will start to spray out of the bottle. So you will need to clean that up. However, When you turn the bottle back onto its proper end, you'll see that the water stops flowing out. This is a really curious trick, and we're going to use it to perform the rest of the prank. If we look up close, you'll see that if I squeeze the bottle very gently, water starts to come out again. But if I let go, nothing happens. And again, if you look closely, when I undo the lid on the bottle, water starts to come out of the bottom. When I screw the lid back on, the water stops flowing. I can even do this with one hand for you, just to prove that there is no trick. Now all you need to do is dry off your bottle and then place it on a kitchen counter where someone can come and try and drink it. Here he is now. Watch what happens. Oh no! The water's going everywhere, and he's got no idea why. Let's show you again, but with a little bit of food dye in the water, just to make this really clear. This experiment works because of the pressure in the bottle. The holes are so small that air can't get in as the water comes out, and so the pressure inside the bottle remains constant, unless you squeeze the bottle and force water out, or open up the lid and let air in. And that's how you can do the hidden holes bottle prank. Walking through paper. All you're going to need is a piece of paper, a ruler, a pair of scissors, and a pen. The first step is to fold your piece of paper in half lengthways. Then take your ruler and your pen and make a series of marks at 2 centimeter intervals along the piece of paper. You'll be left with a small amount of excess. Simply trim that off. Then turn your piece of paper around and make similar marks on the other side. You should end up with this pattern. Then start to trim using these marks as guidelines. It's important that the first trim line that you make is on the folded side of the paper. It might be best to get an adult to help you with this part. Cut most of the way along the paper, but leave about an inch of space at the end. Once you've completed these lines, carefully trim away most of the folded edge of the paper, leaving the very first and the very last piece. You'll see why in a moment. Then go to an open area. Carefully unfold your piece of paper, and you'll see that by cutting it the way that you have, you've created a massive loop that you can easily walk through. This is a great party trick, because if you challenge someone to walk through a piece of paper, no one's going to be able to do it, except you. Do be careful though, because you might tear the paper. It's hard to believe that this enormous loop is made from just a single sheet of paper. And there you have it. That's how you can walk through paper. A great way to peel potatoes. All you're going to need is a chopping board, 2 saucepans, your potatoes, a knife, and a slotted spoon. The first step is to take your potatoes and using the knife very carefully make a line that goes all the way around the middle of the potato. It's best to ask an adult to help you with this part of the experiment, as you will be using a sharp knife. Repeat this step with all of your potatoes. You can use different sizes to see which works best. Place the potatoes inside one of your saucepans. Then cover them with boiling water. Turn on the heat and let them sit for about 5 minutes. Once that's done, fill your second saucepan with cold water. Then, using your slotted spoon, place them into the saucepan. You can also add some ice to the cold water. This will help cool your potatoes down faster. Let them sit for a couple of minutes until they've cooled. Then remove the potatoes from the pan, and you'll see that you can just pull the skin straight off. This is a really great trick. You can show it to your parents when you're helping them cook. If you're going to make something like mashed potatoes or roast potatoes, this is a really great way to speed up the process. It's a little bit messy, but that's part of the fun. A technique like this that helps you speed up an ordinary task is something that you call a life hack. And this is a really great life hack. And there you have it. That is a great way to peel potatoes. Ghost marbles. For this experiment, you're going to need a bowl, a pack of aqua gel beads, and some water. The first step is to open your packet of beads and pour them into your bowl. You'll find that these bounce around quite a lot, so do be a bit careful. Once that's done, take your water and pour it into the bowl. Keep pouring until all the water is gone. Then place the bowl to one side. Leave it alone for a few hours and come back to it, and you'll see that the water has been replaced by these. These are the same gel beads that were sat at the bottom of the bowl, but over time they've slowly absorbed all of the water. So what happens if we pour more water back into the bowl? The beads disappear. Well, that's not quite true. They don't really disappear. They're still in there. What's happened is that the beads have absorbed the water that was in the bowl. This makes them about 90% water, so that they refract or bend light in almost the same way as the water does, making them seem to disappear. If you place your hand carefully inside the bowl, you'll see that you're able to scoop the beads out. They're much larger than they used to be. They're also very slippery. Looking at the bowl from above, it's very hard to tell the difference between the water and the beads. If you look very closely, they look a little bit like frog spawn. You can just make out the edges of the beads. Isn't that weird? It's easier to see the beads if you move the water. Isn't that crazy? And there you go. That's how you can make your own ghost marbles. An invisible flower. For this you're going to need some vegetable oil, a glass and a flower. The first step is to take your glass, take your oil, and very carefully pour the oil into the glass. You'll want to try and fill it about 2/3 of the way. Once that's done, replace the cap and put the bottle to one side. Take your flower and pop it into the glass. You'll see that as you do so, the stalk of the flower seems to look bigger. This is because of refraction. And if you move the flower to one side, the stalk of the flower disappears completely. This happens because of refraction. Refraction describes the way a light changes as it passes through an object. It makes things appear to be a different size, or to be standing at a different angle. This works well in oil, because oil is quite a thick substance, and makes the light refract more strongly. Why don't you play around with it and see what you can do with the flower stem? What's the best place to make the stem disappear? Have some fun with it and see what you can do. And there we have it. That is the amazing invisible flower. How much gas does your favourite beverage produce? You're going to need a glass bottle, some balloons, vinegar, and a frying pan. For our beverages, we've chosen milk and Red Bull. Find a container in your kitchen and pour some of your drink into it. We poured about half a can of Red Bull into this container. Then drop some vinegar into the mixture. We added about half as much vinegar as there was Red Bull. Once that's done, pour the mixture into your glass bottle. Then stretch one of your balloons over the neck of the bottle. If you like, you can use something like a rubber band to make sure the balloon stays on tight. Then place your glass bottle onto a pan. Turn on the heat and watch what happens. As the mixture inside the bottle starts to heat up, the vinegar will react with the drink, and it will help release any gas that's trapped inside the liquid. Because Red Bull is a carbonated drink, this means it's got bubbles inside. Those bubbles are all bubbles of trapped gas that help make the drink fizzy. As that gas is released from the liquid, it starts to blow out the balloon. So from this experiment we can tell that there is gas inside Red Bull. We tried the experiment again, mixing the vinegar with milk. We turned the heat on and stood back for a few minutes. And as you can see, we had much the same result. From this we can say that there is gas inside the milk. In both cases, it's only a very small amount of gas. And there you have it. That's how you can see how much gas your favourite beverage produces. Water race. This is a really fun experiment. All you're going to need is some blue tack, 2 bottle tops, 3 short straws, 2 water bottles full of water, a long straw, a tub and a jug of water. The first step is to make some holes in the bottle caps. Make sure that you have an adult to help you do this. Then carefully place your straws into both of the holes. They should be a fairly tight fit. Make sure that one straw comes out mostly on the inside of the lid and the other straw comes out mostly on the outside of the lid. Then take your other lid, make 2 holes again, and place the long straw through the lid. Make sure that most of the length of the long straw is on the outside of the lid. Then take your last remaining short straw and place it inside. You can easily see the difference between these two. The next step is to take some blue tack, work it into a small shape, and then carefully use it to block any gaps on the inside of the bottle lid. This will help you have greater control over your experiment. Take your tub and place your 2 bottles of water inside. If there are any gaps in the top, use your jug of water to fill up the bottles until they overflow. Then tightly screw both of your lids onto each bottle. Make sure that there is an airtight seal. All that's left now is to turn the bottles upside down and let the water flow. What do you think is going to happen? Will the water leave each bottle at the same speed? Will the short one go faster or will the long one go faster? Well, as you can see, the water in the long strawed bottle leaves much faster. But why does this happen? It's really very simple. At the bottom of the straw there is very low pressure. Inside the bottle there is high pressure. Because one of the straws is much longer, the difference in pressure is much greater, and so water is forced out of the bottle quicker. And there you have it. That's how you can perform your very own water race. Cleaning coins with lime. For this experiment, all you're going to need is a plate, a lime, some copper coins, and a sharp knife. Make sure you have an adult to help you. Place your plate on a flat surface, then place the lime on top. Take a few of your coins to check the size, and then use your sharp knife to make a few incisions into the side of the lime, roughly the size of your coins. Cut 5 or 6 holes so that you can try a few different coins. Once you've cut the holes, place your coins inside, with half of the coin still poking out. It's important that all of the coins you use are copper coins, so for me, it's a 1 or 2 pence coin. What will really help this experiment is if your coins are quite old and dirty. Once they're all inside the lime, leave it to sit for 15 to 20 minutes, or longer if you like. Then come back and pull the coins out of the lime. You should notice that the part of the coin that's been sitting inside the lime has changed colour and looks cleaner. This is because the lime is naturally very acidic, and so will clean off some of the other chemicals that are stuck to the coin. This is a really cool way to naturally change the colour of your money. Why not try this with other coins and see if there's a difference? You can put them all in a line and compare which one has changed the most. And there you have it. That is cleaning coins with lime. Weather vane. For this experiment, all you're going to need is a needle, a pencil, a pair of scissors, rock salt, tape, glue, a marker, some wire, a glass, some card, a straw, and some adult supervision. The first step is to carefully use your scissors to make 2 small cuts in the end of your straw. Make sure that both of the cuts face each other and are the same length. It should be about 2 inches. Then take your piece of card and again carefully use your scissors to cut out a small shape to act as the tail for your weather vane. This tail shape will help catch the breeze and make the weather vane work. Once that's done, use a little glue to make sure it stays firmly in place. Once the glue is fixed on, slot the card into the end of the straw. Then take your marker pen and mark out the other end. Carefully take your needle and push it through the tail end of the straw. Make sure that the sharp point is poking out. And also be very careful. Then take your wire and cut 4 equal lengths. This is what you'll use to make the 4 poles of your weather vane. Carefully bend the wire into 4 different shapes. One the letter S, one in the letter N, one in the letter E, and, yes, you've guessed it, one in the letter W. These 4 wires will act as your 4 compass points: north, east, south, and west. Once that's done, take a piece of tape, lay it out on the table. As you can see, it might be a little bit fiddly. And then carefully lay out each of the compass points next to each other. You need to make sure that you lay them out in the same order that they work on the compass: north, east, south, west. You also need to make sure that they're spaced out equally. Once that's done, check they're in the correct order, and then wrap the tape around the pencil. This might be a bit fiddly, and you may find that the compass points aren't at the exact right place, but you can always take the tape off and start again. Once that's done, arrange them so that they are all at equal distances, and you're ready to go on. Take your straw and carefully place the needle into the end of the pencil where the rubber is. Make sure that the needle isn't pushed all the way in, as it needs to be able to turn. Check that everything's in place, and then place it to one side. Take your glass and your rock salt, fill the glass up, then take your pencil and push it firmly into the rock salt. Make sure that the pencil is pointing straight up. Then blow on the tail of your weather vane to see if things are working. If it doesn't turn, it means the needle is pushed too hard into the rubber. Simply grasp the straw and then turn the pencil on the spot to loosen the needle. Blow again and you should be in business. Now you can of course blow with your mouth, or if you like you can use a fan. That might save your breath a little bit. The principle remains the same. As the wind blows onto the weather vane, it turns on the spot. And there you have it. That's how you can make your very own weather vane at home. Gobstopper Candy Science. You're going to need a tray, some gobstoppers and some water. The first step is to place your tray on the table, then open up your packet of gobstoppers and empty it out. You'll find that there should be 4 or 5 different colours of gobstoppers in your packet. You'll need to separate them out into their own areas. So we've got one purple area, one red, one yellow, one green, and one orange. It's best to try and space the gobstoppers equally apart to make the experiment work at its best. Then all you have to do is pour in some water and wait. Make sure you pour enough water to completely cover the bottom of the tray. Then step back and watch. You'll see that the colour from each of the gobstoppers leaks into the water. That's because the water is slowly diluting the colour on the surface of the sweets. But watch what happens as the colours start to come towards each other. They don't mix. Isn't that strange? Well, not really. When they make the gobstoppers, they use special food colouring, which is designed not to run into other colours. That's how they're able to keep the separate layers of colour in each gobstopper. So, when the coloured water runs toward the next layer of coloured water, they don't touch. So you can make all sorts of strange patterns. If you look closer, such as over at the red section, you'll see that another colour is starting to bleed through. And that's because the water has reached the next layer of colour in the gobstopper. Isn't that crazy? You can make some really interesting patterns using this technique. Try laying the colours out in different ways, or using only 1 or 2 colours to see what happens. I think this is a really fun and really interesting experiment to try at home. And there you have it. That's how you can perform some gobstopper candy science. The science of a plasma ball. All you're going to need is a plasma ball, and probably somewhere to plug it in as well. Once it's plugged in, switch on your plasma ball, and straight away you've got some amazing science happening. The ball is comprised of 3 main parts. There's the sphere on the outside, there's the conductor on the inside, and filling the ball is what they call noble gases. This helps to create trails of plasma. The human body is able to conduct electricity, so when you touch the side of the ball, the electricity is conducted towards you. This is why when you touch the ball, the colour and the intensity of the plasma light seems to change. You can try using different parts of your body, and you'll see that it works much the same way. If you try using other objects like a pencil, you'll find that they do attract some electricity, but not as much. The great thing about this is that you can use lots of different objects, made of different materials, to see what's conductive and what's not. And there you go. That is the science of a plasma ball. Battery train. You'll need some neodymium magnets, batteries, a pair of scissors, and some copper wire. Firstly, pull out a length of copper wire and wrap it around one of your batteries. Make sure that the batteries are AA batteries. Continue this process. Curl the wire all along the length of the battery until you've got a good long spring. Then fix a few magnets onto each end of the battery and place it inside one end of the wire. you'll see that it seems to pull itself through. You can make a much longer length of this curled wire and see how the battery travels through the middle. This works through a combination of electric currents and magnetic fields. This is a really great and simple experiment. That's how you can make a battery train. Copper electrolysis. You're going to need a stirrer, some clip test leads, a pair of gloves, copper sulfate, a piece of brass, a piece of copper, a D battery, and a beaker full of water. The first step is to pour some of your copper sulfate into your water and dissolve it in. The best way to do this is to add a small amount of powder at a time until no more will dissolve. This will turn your water a very bright blue. Make sure to stir the mixture thoroughly. Place that to one side. Then take your D battery and some of your clip test leads. Clip one end of your lead onto the copper and then carefully tape the other end onto the positive side of your D battery. Then take your piece of brass and use a clip to attach that to the negative side of your battery. The negative side is usually the flat end of the battery. Once that's done, we're ready to go. Rest your stirrer on top of the beaker to stop your piece of metal from falling in. It's also very important that the clip leads don't go into the solution, just the two pieces of metal that they're attached to. You can see that our piece of brass and our piece of copper are sitting in the solution but not touching. Now all you need to do is leave this to sit for about half an hour. You won't be able to see anything happening, but once you remove the metal from the solution, you'll see that something has. Some of the copper has transferred to the piece of brass and plated it. This is because the current flows through the battery into the leads, then through the copper, and is attracted to the piece of brass. The liquid completes a current, which allows the electricity to flow, producing a reaction we call electrolysis. And there you go, that is copper electrolysis. Do-it-yourself phone stylus. You're going to need a smartphone, some water, a couple of pencils, aluminium foil, a sponge, sellotape, and tissue paper. You might have seen these phone styluses before. They're just pens that you can use to operate a touchscreen phone. And we're going to show you how to make your own. Firstly, take one of your pencils and your sponge. Then use your scissors to carefully cut off a small piece of the rougher side of the sponge. This is just a typical sponge that you might find in a kitchen. But before you use it, make sure that it's clean. It's best to get an adult to help you with this part of the experiment. Once you've removed some of the rough side of the sponge, make sure that it will fit onto your pencil, then use a small piece of sellotape to stick the sponge around the end of your pencil. This will help hold it in place. Then all you need to do is dip the sponge into the water, soak off some of the excess with your tissue paper, and then start tapping away. You'll see that the stylus works just as well as your finger. This is because the watery sponge acts as a conductive surface and allows the touchscreen to still work. Now let's try the same thing again with aluminium foil. Cut off a small piece of foil, then wrap it around the end of your other pencil. And once again, you'll find that it works in much the same way as a real stylus. However, we did find that this wasn't as reliable as the sponge. Why don't you compare the two and see which works best? And there you have it. That's how you can make a do-it-yourself phone stylus. The power of bleach. Make sure that you have an adult present to help you with the experiment. You're going to need a glass, a bottle of water, some bleach, and some red food dye. The first step is to take your glass and your bottle of water and your red food dye. Place a few drops of the red food dye into the bottom of the glass. Once that's done, replace the cap and put the bottle to one side. Pour some water into the cup. You'll see that the food dye changes the colour of the water, making it a bright red colour. Place the water to one side and then take your bottle of bleach. Carefully remove the cap and pour some bleach into the water. You'll see almost immediately that it changes the colour of the water. If you stir the water and mix the bleach further into it, you'll see that the liquid becomes even paler. But why does this happen? Well, as you know, bleach is used for cleaning, and one of the things bleach does is break down molecules, or rather the bonds between the molecules. In this case, it's breaking down the bonds between the different coloured dyes in the food dye. This stops the food dye from colouring the water, making it turn almost completely clear. You can see that before the bleach is mixed into the water, it still retains its red colouring. And there we have it. That is the power of bleach. Hot ice. It's a really good one. You're going to need a conical flask, a thermometer, 30 millilitres of water, a pan, a spoon, 170 grams of sodium acetate, and a way to heat the pan. I'm using this electric pan. Place your pan on top of the surface, put the sodium acetate in the pan, and pour in your water. Use your spoon to mix the solution together. You want the pan to be warm but not boiling. Enough to heat up the water without letting it boil. Stir the mixture together. You should see a few crystals still inside the solution. What you want to do is heat the water long enough to completely dissolve all the crystals. Once that's done, and while it's still warm, pour the mixture into your conical flask. It doesn't have to be a conical flask, but we found the shape of it helps in the experiment. Once you've poured all the mixture inside, drop some of the sodium acetate crystals into the mix and see what happens. An iceberg starts to grow inside the flask. This is a crazy chemical reaction, and if you feel the flask with the back of your hand, you'll see that it's very warm. This is because your sodium acetate starts to crystallize again. It's a fantastic experiment, and it's really strange looking. When's the last time you had hot ice? If we look at it from the side, you can see the crystals forming and spreading out. This is a really cool experiment. And that's how you can make hot ice. Electric eels. You're going to need some gummy worms, a tall glass, a small glass, some vinegar, a spoon, baking soda, and a pair of scissors. Firstly, open up your packet of gummy worms. These worms tend to be quite thick, so for this experiment we decided to cut them in half. This makes them a little bit lighter, which will help perform a really cool experiment. Once you've cut a few of the worms in half, put a small amount of water inside your small cup, add a few tablespoons of baking soda, and then add each of the worms into the mixture. The aim here is for the worms to soak up some of the water and baking soda mixture. Stir the mixture around a bit with a spoon and then leave it to sit. While that's happening, fetch your tall glass and pour some vinegar inside. It's best to use clear vinegar as you can see what's happening inside the glass. We decided to fill it about 2/3 full. Once the worms have sat in the baking soda solution for 5 to 10 minutes, grab your worms and add them one by one into your vinegar mixture. You'll see that very quickly bubbles start to form. This is because baking soda reacts with vinegar, creating bubbles of gas, causing bubbles of gas to form on the outside of the worms. If enough gas bubbles catch onto the side of a worm, you'll see that it picks the worm up, floats it to the top, the bubbles burst, and then they drop down again. You can try different amounts of baking soda or vinegar to see how it changes the reaction. You can always throw a little bit more baking soda into the mixture if the reaction slows down, and it should speed it back up again. This is a really fun experiment and a great way to create your own electric eels. Coin battery. For this you're going to need some coins, some small containers, a piece of card, an LED light, some clip test leads, a pair of scissors, a pen, some foil, salt and vinegar. Firstly, take your coins and place them into one of your containers. Then pour some vinegar into the container until it completely covers the coins. Pour in some salt and mix the two together. Let that sit for 5 or 10 minutes and then pour the solution out of the cup. Take the coins out and dry them off with a paper towel. You'll notice all of the coins are now very clean. Take your piece of card and draw around the coin. You need to make as many circles of card as you have coins. We used 10. Once you've done that, very carefully cut out the circles. You might want to get an adult to help you with this. Then take your foil, fold it over a few times, and then mark out some more circles. Once again, cut out these circles so that you have the same number of foil circles as you do coins. Take your card and soak them in some vinegar. While that works, place your coins on another piece of card. take one out of the set, then fetch your vinegar-soaked card and your foil circles. Place a circle of card on top of a coin, and then a circle of foil. Then place another coin on top of that, then card, then foil, and repeat this process until you've stacked all of the coins on top of each other, separated with a layer of card and foil. It's important for this part of the process that you try to make the small circles of card and foil as exact as you can, so that they match the shape and size of the coin. Once you've finished your stack, get a piece of sellotape, fix one end of your lead onto the sellotape, and then sit your coins on top. Place another lead on top of the stack, and then stick it in place with the sellotape. You can use stronger tape if you like, but we've used sellotape so that you can see the process. You should now have a stack of coins with a jump lead attached to both ends. Then simply clip the other end of each of the leads onto your LED light. If we dim the light, we can see that by clipping these leads onto our light, it lights up. The stack of coins has made a battery. And that's how you can make a coin battery. Static flyer. For this you're going to need a balloon, a pair of scissors and a plastic bag. Make sure you have an adult to help you with this experiment. Take your plastic bag and your pair of scissors and very carefully cut a thin strip out from the top edge of your plastic bag, between 1 and 2 centimeters in width. Carefully open it up so that you have a ring of plastic. The next step is to take your balloon, breathe in deeply and blow it up. Once you've blown it up, have an adult help you to tie the end off. Then rub your balloon on someone's hair until you see their hair start to stand on end. Then take your piece of plastic and rub it on the same person's hair. Release the plastic above your balloon and watch it fly. Why does this work? Well, it's actually very simple. By rubbing the balloon onto your friend's hair, you pick up a static electric charge. By rubbing the plastic on the same person's hair, you're giving it the same charge, which means these two objects repel each other. By placing the balloon under the plastic, you push the plastic upwards, and because it's so light, it floats. You can try this with different shapes of plastic, like this jellyfish shape, to see what works the best and to see what kind of crazy shapes you can come up with. You can try it with smaller balloons or bigger balloons, to see which works the best. I had a go with this smiley face and it worked quite well. And there you have it. That is how you create your very own static flyer. Homemade glow stick. It's really easy. All you're going to need is a mini LED light, a clear plastic pen, a 2032 or watch battery, and some sellotape. Remove any stickers from your battery so that the metal is exposed. Then slot your LED light around the side. Once it lights up, you'll know that it's on the right way round. Fit it around the sides of your battery. Then use a piece of sellotape to fix it firmly in place. Once that's done, unscrew your pen so that you have just the clear plastic casing. Slot your LED light inside, and then use some clear tape to fix the battery onto your casing. Once that's done, turn out the lights, and there you are. You've got your very own glow stick. You can make as many as you like, in all sorts of different colours. It just depends what colour the LED light is. You can take it outside with you, you can take it on camping trips. Get together with your friends and see who can make the best glow stick. And that's how you make a homemade glow stick. Using a neodymium magnet and a copper pipe. For this experiment you're going to need, yes, you guessed it, a magnet and a copper pipe. This might be the simplest experiment we've ever done. All you need to do is find an open space and drop your magnet down the pipe. If you look closely through the pipe, you'll see that the magnet seems to slow down. You can compare the speed that it falls if you don't drop it through the pipe, and you'll see that it really does fall slower. Something called an eddy field is created as the magnet falls through the pipe. The magnet has its own magnetic field, which in response creates an electric current, a very small electric current, inside the pipe as it falls through. This current then produces a field of its own. The two magnetic fields overlap and slow the fall of the magnet. This is a really great trick and something I find really interesting. The soda can jump. This is a really fun one. You're going to need mug number 1, mug number 2, and a soda can. You're going to need to empty the soda can. Once you've done that, place the can inside one of the cups and blow into the cup. You'll see that the can jumps out. You'll also see that this works regardless of which way round you put the can into the cup. Place the second cup close to the first and blow. Try and aim the can into the second cup. Why does this happen? Well, the can is very light. When you blow air into the space between the cup and the can, it creates an area of high pressure. This high pressured air forms underneath the can and pushes it. The air above the can is still at a low pressure, and so the can is able to move based on the air alone. Why not move the cups around and see what you can do? Challenge your friends to see who can score the most points. And there we go, that is the soda can jump. Tea bag rockets. This is a really simple experiment. You'll need some tea bags, scissors, matches, and a mug. Firstly, take one of your tea bags. It's important that you use a certain type of tea bag, and we'll show you what we mean. Firstly, cut off any strings that you have attached, then pour out the tea into the mug. When you fold out the tea bag, you should be able to make a tube out of the material. Not all tea bags are like this, so look around for a good one. Then place it on a flat surface and take it outside. Stand it on its end and then light the top. The material will burn down, and just before it goes out, it flies up into the air. This is because by the time it's nearly burnt away, the material that's left is so light it gets lifted on the heat of the flame. And there you have it. That's how you can make tea bag rockets. Diving ketchup experiment. For this you're going to need a bottle of water, a sachet of sauce, preferably ketchup. The first step is to take your bottle of water and your ketchup. Then unscrew the lid. Make sure that the bottle is completely full of water. And then very carefully insert the sachet of sauce into the bottle. You'll find that water spills out of the bottle when you do this, but that's fine. Once that's done, very carefully and tightly seal the bottle. You'll see that the ketchup packet floats inside the water. But if you squeeze the bottle, it sinks. Let go and you'll see that it rises to the top again. Why is this? Well, it's because inside the ketchup packet there is also a very small bubble of air. When you squeeze the bottle, you compress the air inside the packet, which makes it denser, and therefore it sinks to the bottom. When you let go of the water, you release the pressure, and it means that the air inside the packet becomes less dense, and so rises back to the top of the bottle. You can play around with this for a while and see how quickly you can make the packet sink and how quickly you can make it rise. If you get the pressure just right, you can make it float directly in the centre of the bottle. Why don't you challenge your friends at this and see who's best? You could even have a race to see who's fastest. And there we have it. That is the amazing diving ketchup experiment. How do you fit a balloon into a bottle? You're going to need some balloons, a pin, a large plastic bottle, some tape, and a jug of water. Firstly, take your bottle and remove the cap. Then stretch out a balloon, place it inside the bottle, stretch it across the neck of the bottle, and then try to blow it up. As you can see, I found this part pretty difficult. This is because of the air trapped inside the bottle, creating pressure. However, if we use our pin to make a small hole in the bottom of the bottle, this will allow air to travel in and out. Now if you try to blow the balloon up, hey presto, it inflates. If you cover the hole, it stops it deflating, because the pressure inside the bottle is unable to change. This is a clever bit of science. But how do we get the balloon inside the bottle? Well, it's simple. We simply pour some water into the balloon. This will help it keep its shape. You can also use water balloons for this experiment if you don't have a normal balloon. Once you've poured enough water in, simply carefully tie off the neck and drop it inside the bottle. And now people will wonder how you ever got it in there in the first place. So there you go. That's how you fit a balloon in a bottle.